Good morning, students. I am Dr.R.Suganya, Assistant Professor, Department of Computer Science with Cybersecurity. Today we are going to see about the user authentication system. Outline: User authentication, password authentication, SALT, challenge response authentication protocols, biometrics, token based authentication. Authentication in distributed system, that is multi-service providers or domains. Single sign-on or Microsoft Passport. Trusted intermediaries. Password authentication is like basic idea we have, like user has a secret password and system checks password to authenticate the user. Issues: how is password stored? How does system check the password? How easy is it to guess a password? It is difficult to keep password file secret, so best of if it is hard to guess password even if you have the password file. User. Basic password scheme here is the hash functions. The user will have the particular password. The password file will be stored as hash functions. So hash functions is like strings are stored as to save as strings, and the given as like password. Hard to find this password means no known algorithm better than trial and error. So user password stored as H. That is, when user enters a password, the system computes and compares with the entry in the password file. So no password is stored on the disk. So it is like hash function is 25 into DES, that is 25 rounds of DES variant encryptions. Password file is publicly readable. Other information in password file. Any user can try dictionary attack. User looks at password file, computes hash of word for every word in dictionary. Salt makes dictionary attack harder. Password file. Here we have the input. We say it is as a salt, and that is ciphertext. The plain text into ciphertext, decryption, encryption with 25, and it compares with the password line. So when password is set, salt is chosen randomly. 12-bit salt slows dictionary attack by the factor of 212. So dictionary attack has some numbers. Typically password dictionary, there is 10 lakh entries of common passwords, people's name, common pet names and ordinary words. Suppose you generate and analyze 10 guesses per second. This may be reasonable for a website. Offline is much faster. So dictionary attack is at most 1 lakh second equal, that is 28 hours, or often 14 hours on average. If passwords were random, assume 6 character password, upper and lowercase letters, digits, 32 punctuation letter, and we have the combinations. So the user authentication is like password authentication, SALT. Next, challenge response authentication protocols, biometrics, token based authentication, authentication in distributed system, that is single sign-on by Microsoft Passport, and trusted intermediaries. Challenge response authentication, that is, what is the goal is Bob wants allies to prove her identity to him. The protocol is AP 1.0, that is, ally says I am allies. So the failure scenario is Bob wants allies to prove her identity. So in a network, Bob cannot see allies, so Trudy simply declares herself to be allies. So ally says I am allies in an IP packet containing her source IP address. Okay, so here Trudy can create a packet spoofing allies' address, and it's this is the failure scenario. The playback attack is like allies' packets and later plays it back to Bob. So the allies sends her encrypted secret message password to prove it. So it records and playback, and it still works. So avoid playback attack. Number are used only once in a lifetime. So to prove allies life, Bob sends allies nuns. So allies must return are encrypted with shared secret key. Allies is live and only allies knows key to encrypt nuns, so it must be allies. Authentication doesn't protect against server database reading, can be authenticate using public key techniques. So next is about biometrics. So use a person's physical characteristics like fingerprint, voice, face, keyboard, timing. Advantages is it cannot be disclosed, lost, or it cannot be forgotten. Disadvantages: cost, installation, maintenance, reliability of comparison algorithms, false positive and false negative, privacy if forged, how to work. Common uses: it specialized situations, physical security. It combines multiple biometrics, biometric and PIN, biometric and taken. Next is about token based authentication, the smart card example. With embedded CPU and memory, it carries conversation, a small card reader, various forms, PIN protected memory card. So enter PIN to get the password, so it will be stored in the memory. So it is like a cryptographic calculator, readerless smart card, which users enter the encrypted result. So the initial data, the time, the challenge. Okay, so some complication is there, like initially the data shared with server, it needs to set up with its securely shared database from many websites. Next is authentication in distributed system, single sign-on, Microsoft password and trusted intermediaries. Single sign-on system, that is we have like username, password or other authentication, and it stores like databases for applications as server. So we all use for this single sign-on system. So the Microsoft password is launched 1999. It claimed 200 million accounts in 2002. Over 3.5 billion authentication each month. Login into many websites using one account. And password may continue to evolve and bugs have been uncovered. So 4 parts of password account, like passport, unique identifier, user profile required to set up account, credential information, wallet. The passport login is there. Here we have the passport user database and passport manager, where it have interacted with the web server and the web pages. So symmetric key problem in trusted intermediaries. So how do two entities establish shared secret key over a network? The solution is the trusted key distribution center acting as intermediary between entities. Public key encryption means when Alice obtains Bob's public key from website email, how does it know it is Bob's public key, not Rudy's? Solution: trusted certification authority. So key distribution center, Alice Bob needs shared symmetric key. So it shares different secret key with each registered user. So they may know their own symmetric key for communicating with KDC. So how does KDC allow Bob Alice to determine shared symmetric key to communicate with each other? So the example is given. And also there is a certificate with expiration. The certificate authorities means it binds public key to particular entity E. It is E which a person and the router registers its public key with CA, certification authorities. Thank you. Thank you.